Hi, I'm Cecilia Wirén, and I want to talk to you about security in a development environment. I have been coding for about 20 years, and half of my time I've been a consultant at Active Solution. So I have been around on a lot of different companies and see what's working, what's not working, and a lot of different like teams and like processes and so on. Latest time I've been working with DevOps, and there's a lot of security in DevOps environment as well. But I think that the whole team and the whole process have something to do about security. And with this presentation, I want to inspire you to get to the next level in your security work and give you a new kind of things to do and tips about something more to do. Because I think this is a journey for you, and you have always something more that you can do. You just need to find it. So I would like for you to think about your development loop or your development life cycle or whatever you like to call it, to be able to have something to work with when you're thinking about where to apply security. And every loop is different, of course, but this is kind of a generic one that I think fits almost everybody. So first you have some kind of step where you're planning stuff, you're grooming your backlog, you're refining your work. You have a box with learning. Of course, all these boxes not like after each other, and they can be spread apart, but learning may be something that you basically don't have in your specified loop, because if you look at like all these different kind of pre-specified loops, learning is a big part, but you may not have it included in your loop today. So you have to think of different steps that you actually do, and not just what's in the papers. Then you do like your coding, you have your building, probably a build pipeline or something, you do some kind of testing, unit testing, integration testing, acceptance testing, manual testing. You have something when you release your application. After you do that, you may have a monitoring space, and then you have like your feedback box where you have like your lesson learned or retrospective or something where you look back and reflect on stuff. So I would suggest that you draw up something similar, just to be able to have like different kind of boxes, and then you focus on one box at a time and try to figure out what could we do more here. So this talk, I'm going to follow this line, and I'm going to give you some kind of tip you can do here that hopefully you don't already do. So we start with planning. And I want to tell you a story. And the story is about two mobile phone companies. We can, and this is in Sweden. It's an actual story, but we're going to call it Company A and Company B, just to don't point fingers at someone. So Company A have outsourced their like customer services, their sales, everything that's doing with customer to a call center. And Company B has also outsourced everything that happens to be managing the subscriptions, to supporting and selling more subscriptions on to a call center. And it's the same call center both are applying. That's completely fine. It's basically what most of the company do is they use the same company because they are best on just this one thing. But there's a problem. We have a very clever sales guy here. So this sales guy, he probably is measured on how many new sales he does. So he has this database of customers from Company A here. So, and then we have the Company B here where he wants to do new sales. So why don't he look in this database and call up them and try to sell them contracts over here? And that's exactly what he did. So he continued doing this for over 6 months before he got caught. He extracted 32,000 customer information from one company. And this is kind of a different threat that we don't talk about as much. because he's not a hacker. He had a legit accounts. He had a logins. So he just was clever and smart and did something that probably wasn't allowed, but he didn't kind of force himself into the system. So when we talk about what we want to do, when we create a user story or whatever we call it, we only mostly think about what you want to do, what you want to achieve, what do person A, B, and C in the operation company want to have. But what we also need to do is like doing, instead of just user stories, we need to create abuser stories as well. So we think about the things that we don't want to happen. So in this case, we had this compromised salesperson. So instead of creating actors or personas, we're going to create threat actors, people that want to harm us in some way. And a story here could be something like, it could not be easy for a salesperson to extract large amount of data. You know that button, extract all to Excel. Maybe we shouldn't allow that. At least we should track it, who uses it. Another one can be when a salesperson look at the customer data, it should be tracked and alarmed if it gets usually high. So if we have like the same person is looking at more customer than is common, then we get an alert or something that we can follow up and see if this is correct or not. Yes. Other things we can do is basically when we are using our items or backlog items or whatever we like, we are touching them and adding kind of metrics on them. We specify a better title, a better description, maybe we're adding a different definition done. What we can do here is to think about if we have an issue or a request or user story, whatever you call it, and this story happens to be about adding a new phone number, and phone number field is needed on the form, and so, etc. And all kind of input from users are security. It could be a security issue. So this backlog item, I would kind of tag it or something and say this is a secure. Here we have something that could be a security issue. We could add a security definition of done, and that's more like what should you not be allowed to do. So in this case, you shouldn't allow like SQL injections or DOM injection on the error message, or maybe you need to encrypt data as well. So if like the whole database gets stolen, they can't read it. So different kind of like security you don't allow, you don't want to do, you can add as well. If you're doing metrics like sizing, effort, maybe you can add a risk metric as well. So if this is a high risk item, you classify it higher and then you do something else with it later on. And you can even change the visual appearance on it. It can be a different color, it can be different type or something. And that should be an indication that when we are working on this one, maybe we need to be more people on it. We need to review it with 2 people instead of 1. When it comes to testing, we need more testing. Maybe the tester should be aware of that it's more to think about. So just highlighting and describing that this is something that can impact security and have it all during your life cycle could be a great help. Well. So, of course, there are more in every box, but we only have 50 minutes, so I'm skipping to the next one. Learning. This is the most important thing here. You probably learn much today, both here in the conference, but also when you're working. There are constantly new things to learn in the development environment, and security is not an exception. So, if you don't learn, you don't know what threats you have to be aware of and what you could do and so on. And of course we have the regular thing like conferences, books, online resources, hire a tutor, hire a teacher, whatever you like. But I have 2 things tips what you could do. You can actually dedicate a complete sprint or a day or whatever time length that is best for you for a security sprint. So in a security sprint, you could either create those abuse stories, trying to figure out what kind of thing can you do to exploit the system and try to create the abuser stories for them. You could also involve everybody, like the project owner, the testers, and you're trying to hack your system together and trying to find things that you can do. You can focus around some kind of special security issue. You can focus on like injections. There's more to it than just SQL injection, so you can start by learning all the stuff around injection, and then you try to find the same in your code. So you have like a boot camp or a theme around security, and you focus on it. And to get a little bit inspired on if you're doing themes, is that we have two lists that we can go to. The first one you may have heard of before, OWASP Top 10. OWASP is a organization that have a lot of security stuff, and everything is free. There's a lot of papers, there's a lot of tools and so on. So that's a really, really good way start to find things that are free and start using them. And they have this list called Top 10 Most Critical Web Application Security Risk. And that could be a good start to pick something on that list to work on, to educate yourself or trying to find in your code. We also have something called SANS Top 25. It's more a general software errors. It's a long list, and it's not only for web, so it's more classifying things as well. So those kind of lists is good to learn from and inspire to secure your code. And when we want to learn stuff, it's best to like try things out. And if you can do it as a game, it's even more fun. So I suggest that you organize something called Capture the Flag. This could be like an event that you have teams, you compete with each other, or one by one, or it can be more like an education thing you do together, explore and trying to learn. So you don't have to go all out competition. You can do it like a more soft, nicer activity as well. But what you do is actually that you become the hacker. So you are on the other side trying to hack like a web page or something. Or depending on, there are a lot of different capture flag platforms that you can use. Some is more educational, or more is just like hacking. From the OWASP organization, we have something called Use Shop. And that one have a really good education baked into it. So you don't have to like you can just jump in. You don't have to read things beforehand or jump out, but there are things that you can do with like click here, click here, click here, and then you have the next level is more like look at something like this. And then there's a hardcore level as well that we just state what you want to do, they want you to do, and then nothing. And you collect flags. So for every puzzle, if you call it that, you get like a point. And then you can compete and compare yourself for that. So that's really nice to set up and a fun way of doing it. And then this is a good thing for like a theme day or half day or something, what you like. Yes. So let's move to develop. And let's include build in the same. We don't have a lot of time. So that's here where we have like the coding, the build pipelines, all that stuff. And I want to start talking about the code, the actual code, the core about it. But I don't want to talk about your code. I want to talk about the other code. And I don't mean the other code that your colleagues is writing. I don't mean the code that you copy-paste from Stack Overflow. I'm talking about the code that comes from open source. Those kind of code that you are using. And there are the different kind of numbers around, but I think in average 90% of the components in an application is open sourced. And depending on what kind of platform we are working with, so basically 1 out of 10 downloaded packages have vulnerabilities. If you are looking at the JavaScript side, it's actually half the download packages that have known vulnerabilities. So there are a lot of packages and a lot of packages that are vulnerable. So this is an important area to discuss, and we have a couple of incidents around this area that have hit the newspaper as well in a couple of years. So I hope you have started to think about this anyway. Let's take an example. So this is about struts, Apache struts, and that's a free open source MVC framework for Java. So if you're a .NET developer, you may never have heard of it, but this is really popular. And they find a security issue, so was about ejecting script. So more or less, you can bring your code to the platform. So that's not a good thing to have. So they patch it in like 1 or 2 days and announced, here's the new version, please update. But everybody that was using it wasn't updating. So this happened in March. And the time went by, April, May, June. And in June, it's actually a higher amount of download on the broken packages than it was in March. So on the statistics, it feels like no one was updating. And the time went by, July, August, and then in September, someone got breached. And it was a company called Equifax. Equifax is a company in the US that is handling a lot of economical things for people, like personal credit cards and accounts and personal number, all this kind of the most holy secret thing you have on people. So they got hacked. They used that platform. They get hacked. They got a breach on 147 million customers. That's more than 14 times the Swedish population. And they got a fine, a little fine on $700 million. So for them, there was a big impact to not managing their open source. It doesn't have to go this way, but it can. So the big question is now, what can you do with open source things? And the first thing you could do is start to inventory, to think about, are my packages up to date? And of course, if you update your package, you could get a new bug, but you're more safe to update than stay on the current version. Because if you are using a current version that have some security issue, that's going to be known. That's going to be, hackers going to start to explore it. If you have a new one, the odds is that this not spread, and then if you move to new one next time, you're going to jump over it. So you're more safe to stay updated. You can also look at like the complete package and ask yourself, is this maintained? Who's behind it? Is it just one contributor, or are there more? Is this a package that you can trust? And the last thing, do you really use it? Maybe you have the package laying around, but you actually haven't used it anymore. Maybe you don't need it anymore. You can replace it with something native in your platform that wasn't around for a couple of years ago when you added it. So just grooming a little bit there. So basically try to limit the risk. As I say, remove and stay up to date. You could limit the sources as well. So if you would take depending on the sources, you could like host your own and not allowing to go everywhere else, and then you could only allow what you want to allow for this stream of open source packages. So there are a lot of things like that, and there are a lot of tools here that can help you to be able to go through all your open source library and look and see if it's updated, have it a security issue, and so on. It's kind of hard to do that. There are something included in like GitHub or something like that, but there are also free tool or pay tool that you integrate with your pipeline, or just as scanning, or even directly at your IDE in a local machine as well. But take help with tools here to stay on top of it. So now I want to come back to the code again, and I want to talk about your code. And we're going to do a little bit of experiments soon. This happened to be a bug in iOS 7. It was something that they could do a person in the middle attack, basically, because the SSL verification was broken. So I have the actual code. The code is C++, but it looks that it could be C# as well. So what I want you to do is everybody going to stand up in a little bit. You're going to look at the code. I'm going to take time. And when you find something that you think is the bug, you're going to sit down. And we're going to see how fast you can find a bug. Okay? That feel okay? So everybody rise. So, everybody's ready? Okay, you can stand on your chair or something if you don't see. There's a long person here in the front. So, let's start. I didn't start the time, I find my phone. So you get an extra time. I'm not going to call out on you to say the error, so you could just, when you think you have something, you can sit down. So you don't have to be completely 100% sure. It is hard for everybody to see. Sorry. Almost. Yeah. So we can stop there. Almost everybody was sitting down under a minute. So, and where was the error? It was here. You know, if you don't have a block around the line, then the line becomes a block. So this is like this is not because it's moved in, but it's actually on its own row. It's not together with the if statement. So we don't going to run this code at all. The go-to is like moving your way to another part of your code. You can actually do that in C# as well, but don't do go-to. So what I wanted to prove here is that if someone more is looking at the code, then they may see something that looks strange. So if you've seen this one and you're not sure this is a bug, you can ask them, is this intentionally or did it happen to be an error? So what I want to encourage here around testing is that more people looking at the code. And that can be done in many different ways. One can be pair programming, where you do have a driver and what do you call the other one? A driver and a co-pilot, thank you. You can do mob programming. Mob programming is when the whole team is going together and we have one driver and all the other team is discussing what to do, and then we have like someone that is telling that person to code, okay, we decide on that. And you have and then when he's coding, the other team can talk together again. And you can do reviewing of code, pull request, so someone have to look at the code before checking in. And here also where you can use the thing we did with stories, where we tag them for security. Then then if you don't do pair programming, usually you may do it on like the security stuff or the important stuff as well. And the last thing under like coding that I want to talk about is your secrets. So of course you have secrets in your code that you need to handle in some way. You have to make sure that you hash your password correctly if you have your own database for that. You need to make sure that you don't have password in your config files, that you collect them somewhere. Maybe you can remove your password at all. You can, like in if you're Azure environment, you can just manage identity, then you don't need a password or any kind of ID for that as well. If you have shared secrets between the team members, you need to have some kind of password management, so don't copy paste and have them in the wiki and stuff like that. So that could be an exercise to just go over everything, your code, your wikis, your routine. Do we have any secrets laying around that we should remove and change when we have removed them, of course. Yes, moving on. Testing. So here we have things like unit testing, manual testing, acceptance testings, etc. And I have an example here as well. This is also a Swedish company. It's a landlord company. They had a little fun bug on their page. They are using bank ID to log in. And while you were logging in, like when you're switching devices back and forth and trying to figure out things, you can actually, while it was trying to authenticate you, you could start to browse my pages without the system had approved you. So you can basically put anyone's personal number here, as long as they are customer, of course, and then go to my pages and cancel their contract, for example. Not so good. And there are a lot of a lot of things that have happened here. But one thing that are not too uncommon is that the developers that work on this page had to log into the bank ID over and over again to test things. And they did a shortcut to be able to come inside without logging in. Could be. I'm pretty sure it wasn't that, but we pretend it for this story to hold up. So what can you do with that kind of things where you're doing like backdoors? I think it's 4 kind of things you can do. First though, you can add directly in your code that you need to have your ID here. So this is an if statement to state that your Visual Studio is basically attached to the code. This will not happen in production. So this is kind of safe to put like your shortcuts code here. You could also use the debug directive. Make note that you don't compile your code with the debug flag, otherwise it will not work. The third thing we can do is write a test about it. So if you have a test pipeline that you do unit testing on, maybe on all check-in or when you're building and creating your release package, you run your test. And why not add a test that checks that this backdoor is turned off, that you have commenting out that block of code or how you do it. So when you're adding a backdoor, add a test, and then you're sure you're not gonna, you may not check in, but it will stop at the testing. Or do like a test instruction for it. If you're manual testing or automatic testing, you can add it there as well. So the backdoor that all the different developers are using aren't there, basically. Yes. Let's see where we are now. Release. I don't have a story, I don't have a slide. But release, sorry, I have one. The release step, when we are ready to release it to the public, we could hire a pen tester. This is expensive. You're going to get a report that is huge. You may not manage to handle it. So this is like the last step. Some of you may have done it, but it's not for everybody. What you can do then is more like an automatical pen testing. It's not pen testing per se, but the same thing. So there is tools out there that can try to hack your page in an automatic way, we could say. So once again, OWASP have this SAP package that you can use, set up an environment and then use this one to like automatically trying to hack your page, and it go through a couple of different rules and setup and so on. And of course there are more products as well, but this is a free one. It's a good start if you haven't done it before. Monitoring. Here I don't have a slide or story. So monitoring is more like when the app is actually running out in production. So if you're monitoring things, you can know what's happening, you can alert on things. So if you think back on the story on the phone company, and monitoring is about making sure that you know how many views every salesman does. If you do a lot of extraction of data, you get alert, or you just log everything that happens. So that when you have an incident, you can go back and look what's happened, more or less. So there's a lot of good value in good monitoring to see what's happening, or even alerts and things like that. And the last box, as I said, this is not the only thing you can do in every box. You need to sit down with your own the loop and trying to figure out what you could do. But I hope there's a lot of new content for you here. So in the feedback, as I said, this is like lesson learned, retrospective, you're looking back. And you could look back on your own fault, and if you had an incident yourself, you're going to talk about it and try and figure out what you can do so it's not happen next time, more than just fixing the error. But you can also look at some public thing that happened, something that's in the newspaper or an old thing or something. And I think I'm going to do this together with you. We have an incident, this is kind of old, and we're going to do a little takeaways from that, some example. So I want to talk about heartbleed. And this is called heartbleed because the function it explodes is called heartbeat. So what it is so this is a server. When we have a server, we have a client, and the client wants to stay connected to the server, like if you have your email client or something. So it needs to ping back to the server and make sure it is online all the time. And you don't want anyone to answer. You want to have proof that it's actually the same, that's real server. So you, as a client, send like an encrypted message to the server. And the server is storing it, decrypting it, reading it up from the memory, and sending it back to the client. And it's proof that that it's the server that's answering, and you have something that is keeping the connection open, basically. So that's how that functionality works with a heartbeat. So the exploit, it works like this. When you're sending your encrypted message, you also tells the server how big it is or how long it is. So the server is storing the message in its memory, and then it's going to send it back. But you have told it how long it is. But what about if you lie and say that it's longer than it is? So you send that length of message, but it tells that it's double long. So when it's going to read it up, it's going to read the amount that you told it. It's not going to check that it's the correct number. So it's actually going to read more from memory than just your message. And we have memory. Things in memory will lay around. in memory until it's get overwritten. So basically you could write a tool that was going back and forth to the server and reading the unused memory. And what do we have in the memory of a server? Secrets, keys, private keys even. So this is really a bad thing to have. And there's actually a lot of servers still having this error on it as well. Scary stuff. But if we, except for what's wrong and so on, we more think about what to learn here. So the first thing we can learn is that this was an unfunded open source library. So the quote from Eric called Linux Low, pretty strange why it's not called Eric Low, but given enough eyeballs, all bags are shallow. Meaning that the more people that look at the code, the more people that work with the code, the more it's more expected that you find your bugs. So this was a big ball of old code, more than 20 years. It's open source, so everybody could look at the code and find the error, but it's been around for many years before someone found it. So that's the first lesson from this story. They actually get more founded, got a lot more money from like the big corporation that was working, using this product and so on. So they could actually work on it full time instead of just a hobby. And the second thing is that the code base was 20-year old. It was managed by people that haven't time to do much stuff, so they just fix the problem and fix the problem and fix the problem. And you know, a 20-year-old code base that can be kind of massive and spaghetti code and so on. So the second lesson here is to keep your code clean, to refactor your code. It's okay to add things along the way, but as time goes by, maybe the code became more complex. You need to refactor it. You might look over the naming and so on. So if you have a complicated code that don't need to be complicated, and you do like pull requesting, and you look at the code and you're trying to figure out what have this person done, you may do more of your time looking at your code and trying to figure out exactly what it's doing, or you're just looking at the exactly code rate that line that he wrote, and like it's currently okay. If the code is clean and good refactored, you may have easily to understand if the thing that your colleague have done is the correct one, and if it's not introducing new bugs. So it's important in a security way also to keep refactoring your code and make it simpler and easier. And the last thing, where you're hosting your code. It's not just only your code, it's also where you run it that is important. You don't want to run it on a Heartbleed server. And I have a favorite tool here. So if you have a public page, you can run this tool and get like a grading. So this is actually a real grading from a customer that were hosting their own servers on a third party, and they were not doing their job. B grading is not good. And you can drill down and see what is causing this rating and see what you can do about this as well. So I really love this tool. It's really fun to use. It's the Qualysys SSL Labs. So you can play around with it and see, look for broken pages or your own. And sometimes you are responsible for the environment where you are running it. You may be using like Docker or infrastructure as code or similar. Then it's actually your code that's doing the hosting unsecure. So you need to make sure that your configurations or code is correct. And that's hard because most developers aren't too aware of like networking and stuff like that. But there is tool here as well. So if you are using these kind of things, look up a tool that can help you scan and approve your configuration or code as well. That's a good point to have as well. Actually, I have a colleague of mine that's going to do a infrastructure code count battle thing on the last session. And don't believe him when he don't say that Terraform is the best one. So, we have gone through all different steps. Planning, backlogging, marking up your issues as important. Think about security, talk about security. Talk about security with your product owner. Talk about security with your testers. Talk with everybody that we work with security. Learn more stuff. Do fun things. Do similar things that you do with all kind of other development. Go to a session about security. When you're coding, you can have tools in your IDE that helps you detect if you are doing an SQL injection. And that's true for everything here. Try to find tools that help you and learn more stuff on how to do stuff. Make sure not to have secrets, either in code or beside. Building, the whole thing about DevOps. I haven't talked about that, but there are a lot of tools in the pipeline. You can make sure that you have checkpoints for people looking at the code, pull requests. You can have tools that scans your code every night. You can have things to look at your open source status to see if you have vulnerability or need to upgrade something. Testing of course, testing security with tools or with code. When we release, we can also test more. Monitoring, make sure that you know your system so you can go back and look back in the mirror. Think about what you have learned. Think about what you're doing. Is it working? What is working for others? What's working for us? So that's my encouragement. Work around your development pipeline. Never stop to iterate on security as well. So, security is everybody's job. So go out there and do more secure code. Thank you.